All right, this was from our classwork, our participation, the video that we watched. So let's go over it here. So it says Polly planted a magnolia tree in her front yard. Okay, cool. You know, she planted the front, not the back. When she planted the tree, it was already 4 feet tall. Okay, cool. At the end of the year, she measured the height of the tree. Below is the table of the data she collected. Use the table to create a linear graph of the data. All right, so it looks like in the first year, well, actually, no year, it was already 4 feet when it got there. So when she first got there, it was 4 feet, right? Not 0 feet, not 2 feet, but what? 4 feet. All right, so let's go here. Let me erase that. 0, 2, and 4 feet when she first got it. So in a sense, you can see this 0 here as when she first got, well, what is it? Got the magnolia tree. So when she first got the magnolia tree, okay, it was already 4 feet tall. She didn't have it for no time, anything like that. It was like, boop, 4 feet when she got it, the moment she got it. All right, so then what happens the next year is that this thing moves up to 6 feet. Okay, cool. So the second year moves up to 8 feet. All right. And third year, 10 feet. It's got a little pattern going, huh? Let's see what the pattern is. And then fourth year says 12 feet. Cool. So we got a straight line. So we know we got a kind of pattern going here. Please excuse my straight line. It's not going to be the best. Okay. So we know we have a pattern going here. Okay, cool. So that's the graph of it. Nice. All right, let's go on to the next stuff here. So it says on the same day Polly planted the magnolia tree, she also planted a pear tree seed. Okay, cool. So that's important, a seed. All right. The equation below represents how fast a pear tree is expected to grow each year. X represents the years, and Y represents the height of the tree in feet. Interesting. Notice what they didn't give me. I didn't get no table of values. All right. Anyway, 0, 0. So let's go over and let me erase that. So no table of values. Now, what type of equation is this? You don't see a C term. You don't see plus 7 or anything like that. I mean, you could technically put plus 0, but remember, mathematicians are kind of lazy, not going to do all that work. So we just leave it at that. So this is what we call a constant of proportionality equation. Okay. This is not your slope-intercept form because it doesn't have like a plus 7 or, something like that. Just your constant proportionality. All right. So everybody know the rule with that one. When you're doing constant proportionality, you're always going to start it at 0, 0. Now, what does 0, 0 represent here? When it comes to this pear tree, it represents the seed. Because remember, the seed ain't got no height, nothing. When she first gets it, remember that 0 point when she gets it, that seed is like 0 inches out of the ground. It's actually a little bit under the ground. Okay. All right. So that makes sense about that 0, 0 point. Okay. So 0, 0, cool starting point. And then what happens the next year? Oh my goodness. The next year. Okay. So equals the year and then the growth. I think they said the growth was in what? Hold on for 1 second. The growth was in feet. Okay, so the growth was in feet. All right, so we got a unit rate of source, right? Because we have a year compared to a foot in that situation. All right, so let's go over here. So if it says that this thing at the 4 years is going to grow, excuse me, not at the 4 years, I apologize. At the 1 year, it's going to grow 4 feet. Boom. Okay. Well, let's see what that looks like mathematically. Okay, so we go here. I'm going to do some erasing, y'all. So let me erase this. Boom, boom, boom. All right, so let's go here. So let's go. So then we said the first year, how tall is that pear going to be? 4 feet. Okay, cool. Let's go over here. How about the second year? Goodness gracious. It's all the way to what? 8 feet. Okay. And let's go ahead and do the third year. What is that? 4 times its third year. Okay. So, and then we can just say more like how regular people might say when they're out there. Hey, after 4 years, the thing is four. No, wait a second. So 12. This actually needs to go up some here. Oh, there it is. Okay, I'm sorry. Gotcha. All right, I was looking at 14 crazy, but 16 over there. And so then notice how this line just boop, 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 continues on right there, okay? All right, so let's just go over this once again. It was at 0 because remember it was a seed. Seeds don't have any growth. Actually, they're underneath the ground, okay? So this thing ain't even got a measurement. So when they first got it, small seed. What we found out though is that the first year, this thing was bursting out 4 years. And by the second year, it was already at 8. So, since it doubled. All right, so let's go down and take a look at our questions. So it says, using the information you have in the magnolia tree and the pear, answer the questions below. What is the unit rate for the magnolia tree? Blank feet per year. So what I'm going to do now is we're going to go ahead and take a look at some of these error analysis here. So let's look at the first one here. So for that magnolia tree, we had some students that said their unit rate was 1/1, 0/4, 6. So take a look at these answers here. I'm going to ask you, what do you think these students' mistake was in this situation? Let me pull this back up so y'all can take a look. All right, let's go up here to the magnolia tree and take a look at that chart right there. The growth starts at 4 feet and keeps it increasing by a rate of how many feet after 4 feet? By 2. Okay, so why would somebody probably put 4? Let's take a look at those answers one more time. Let me toggle back. Why would someone place 4? Now that you kind of know this here, why would you use 4? Okay, so let me go to my little tool here. Okay, so look at this answer here, 4. Why would they choose 4? I think we kind of know. Can I have someone weigh in on that one as well? This person choose x equals 4. 4 equals x. Then some of the answers that you're seeing here, I think students just really didn't understand what the challenge might have been. Okay, another one here. Why did this student choose 6? 6. Think about that. Okay. So the ones I want to ask students to go ahead and explain what they thought the students was thinking of are when you see 6, 4, and 6 and 4. So let's go back. All right. Oh, wait, hold on. Let me toggle out. Okay. Oh, wait. Oh, I know why. Sorry, guys. Okay. So let's go back here. All right. So we can see that. So what is the true answer here? Let's go down. Looks like for every 1 year, it increases by 2 feet. Okay. Year. Well, let's lay this out. One thing we definitely know as we look at this is that, let's go up actually to that challenge. One thing we definitely know when we see it is that this thing is not going to be a constant proportionality because it don't start where? It doesn't start at 0. So we got the classic y equals mx plus b situation. Okay. Our movement on the y-axis will be dictated by the rate of change. But before we get to the rate of change, we're going to go in at the starting point. So 4. So understand, our movement on this y is going to be dictated by these things here. So then, what's the rate of change as we saw? Looks like it keeps increasing by 2 feet. And there we have it. So let's take a look and see if this really does work. So I'm going to go ahead and take 1. So if I go over here and go, let me do some erasing, y'all. Erase this, erase this. So let me actually erase this. So if I go over here and go y equals 2, we have 1 here. The value of 1 plus 4, that's going to be 2 plus 4. Where should I be on my y-axis? At 6. And I'm at 6. Let's do another one. Erase. So put a line here. So then where I should be on my y-axis, the height of the tree, once I take that constant rate of change times the amount of years plus the original height of the tree. So what I want you to do now is I want you to go ahead and plug in that. On a separate sheet of paper, I want you to do this one and this one and see if you get the same answers that are here on this table of values. I'm going to go ahead and do 2. So the second year of the tree, how tall will this magnolia tree be? So the original height was 4 feet. At the 2 years, there's going to be 4 additional feet on top. I'm at 8. So let's look and see. 2 and 8. Go ahead. See if you can get the correct answers by using that equation and putting those points in as well. All right. Cool. So we got that unit rate. Let's take a look at the pear tree. It says, what's the unit rate for the pear tree? All right. Let's go to the, where's my little, there it is. All right. So part B, mistakes. All right. So let's take a look here. We have some students. Okay, so give me a second. So there, what I'm going to do though is I'm going to toggle back and go up to that challenge and take a look at it. All right, let me get there. All right. So let's go up to the pear tree. So one thing we notice is that the pear tree wasn't a tree when she first got it. When Polly got it, right, it was a seed. Bing, we had 0. Okay, so we notice after 1 year, my right triangle right there, after 1 year, this thing finally grows 4 feet. You notice the work that we did already on that one. We didn't, we already had, excuse me, how do I say this? We did this work for the constant proportionality equation, just like the way that y'all did the work for the slope-intercept form. Okay, what was it missing? Remember, we're just missing that starting point. Okay, it's not starting at 4 feet. Okay, so this one starts as a seed. So then what's our rate of change? After 1 year, this thing keeps on, it grows 4 feet. Let's go down here, answer that question. All right, so I have 4. Oh, they already have the per year. I'm just going to go ahead and put 4. I didn't even so caught up in writing ratios. Let me erase that. There we go, 4. You can represent it as 4 over 1, like I did over here. If you had put 2, it would have been fine as well. All right, so which tree grows faster? Well, let's take a look here. It looks like the old magnolia tree is popping off at 2. All right, and it looks like the, what is that? The pear tree is popping off at 4. Let's do a wind up because fractions are intimidating. All right, how many sets of 1 are in 2? 2. All right, let's bring down our blank space. And how many sets of 1 are in 4? 4. All right, which sign I'm going to use there? You already know that inequality sign. So it looks like that pear tree is moving faster than the old magnolia. Okay, so I will go and write pear here. Just pear tree. All right, take a moment to think about what I just said here about the pear tree. If you have any questions, please pause me or pause the video, or just pause while we go into the video and let me know. So when we get towards the end of this challenge, it says draw both of your graphs onto the graph on the right. Circle the point at which the two graphs intersect. So I think the first one was 0, and then it was going every 1 year. And that's the pear tree. There we go. So the pear tree, 1, 4. So then 2's gone to 8, and then was that 3, 12. Yeah, because 3 sets of 4 is 12. 4 sets of 4 is 16. Okay. So let me change colors on the pen. Let's make it red. Okay. So I go for this one as a unit rate of 1 and 2. Okay. So for every 1 year, it's going to go 2 feet. Oh, am I making a mistake? Yeah, I'm making a huge mistake when it comes to magnolia tree, right? And what's my mistake, ladies and gentlemen? I'm doing the rate of change. I need to do what? I need to do where that tree starts at first. Let's see if I still have that same color. So let's go here. It's going to start out at what? 4 feet. Okay. And then from there, it's going to go 1 year, rise 2, 1 year. And notice how I'm using, I'm going to show y'all. Bing. Bing. And just like that, notice rise, run, rise. I know y'all like to, prefer to say rise or run, but anyway, run, rise. And then notice 2 is going to be at 8. Then from 8, if I add on to another year, it's going to raise up 2 more feet. Another year, 2 more feet. Another year, you get the idea. Okay, so let's go over here. Let me lay my line. Let me erase this. Erase. All right, so let me go ahead and make my line. Oh boy, it's not going to be the straightest, but you guys get the idea. Okay, so now let's go and get my other line here. Okay, let's see what it do, where it meet. Okay, so 0, 1, 2. Okay, so on the x-axis is 2. Let me put that X over just so y'all can see. Okay, and so then from there, I'm going to, because that's my, let me get another color so y'all can see. Because remember, that's the bottom part of my triangle right there. Okay, so you can, oops, that's kind of a bad line, but you can see. And then from there, and also even from this one here, you can see sort of right triangles. All right, so anyway, so I go up there, then it says, oh, 8. All right, so I have 8. So, guys, remember, look, I move out to 2, and then as I go up from, and move over to 2, it's going to be at 8. All right. So we have that point there, but so it says, what does this point represent? Let's go ahead and take a look at what some students put so we can talk about this. What does the point represent? All right, let's get a little bigger here. So we had some people responding in some interesting ways. We had students say, the point represents a difference in growth between the trees. One has a faster rate than the other. That's a form of answer, but that's not the clearest answer in the situation that we're looking for. The tree growth, I didn't understand that one. It represents how much the tree grew by feet in 4 years. So you can see they kind of got things mixed up there, all right? 2 or 4, I'm not for certain what that means. This person put that it represents the height in feet. I mean, that's true, but that's not really what we're looking for in a situation here, you know. Actually, I mean, yeah, you're right. They're using feet to measure, but you know. And so you can see some of the mistakes that students made there. Let's go and take a look at some of the correct answers that students had here. Let me pull this out. Let's see. Can I make this? All right, let's put it over here. So Brandon Cruz had put both tree unit rates lines intersect. So that's one answer you could have gotten, okay? Kevin, this is the point where the pear tree will start growing larger than the magnolia tree. Another perspective. Miss Laura, the point where the two lines intersect represent when both trees were the same height at one point in their growth. Mwah. Really enjoyed that sentence there. Mr. Cruz, is when both tree unit rates intersect on the coordinate plane. Okay, not as quite as fancy as Miss Laura's, but I get the idea here. Miss Hastings, that point represents when the trees are the same height. Love it. Right to the point and clear. Samara, the point represents where the two lines meet. Okay, intersect, meet. All right. Is it better? Would I like Miss Laura's a little bit because it just puts the intersection and says the real world example? Yes. So, but not bad. Amelia, this point represents the same point in growth at the same time for both trees. Nice, nice. Nicholas, you would have long sentence, man, to cut it off. This represents how both trees are compared. Okay, that's true, but we can conclude. So he went a little deep, and I was like, okay, I'll give him credit. Let's go ahead and take a look at other student. So part C, correct. And this is for Group B. So for Group B, let's take a look. Kevin Saguero, I hope I said that right. This represents the start of the tree that grows faster and bigger. Yes, now, would I've loved for you to say it a little differently? Yeah, but I see where you're coming from, man. So yeah. Leilani, this point represents when the two trees were at the same height in feet in 2 years. Nicely done, young lady. Mr. Cruz. The point represents where both graphs intersect. Yes. What I would like added on to that is sort of like what Leilani said. She also gave the real world perspective if you were talking to a person. Hey, that's when the trees finally meet the same height. But technically, you're correct. Mario, an intersection. Can I get a little more than that? I mean, you're technically correct. You're a great kid, so I get it to you, but I would need more than that, please. Eduardo, the point represents the year that both trees were the same height. Nicely done. Miss Leon, the point represents that in 2 years both trees grew 8 feet. Another way to see it, okay? Monse, the point that I circled means where the two lines intersect each other. Yes. Now, can I get some real world talk on that as well? Okay, about the trees, that would be perfect. And Maui, the point when the two lines meet is the time of year when they are both the same height. Cool. All right, so let's go ahead and go back here. And I think that's it. Yeah, so we covered, let's see if I can pull this over some. Yeah, we covered this pretty good. If you have any questions, make sure you reach out to me. You're going to see this kind of stuff on your quiz on a Thursday, so make sure that you understand. Okay. All right, that's it.